Hello everyone. We've been hard at work on an upstream pull request for an offline mode for the Hydra node. This is one of our Fun 10 Catalyst proposals, and so as that's nearing completion, I wanted to record a short video to show you what that's about and how you can try it out for yourself. So the offline mode is a mode that you can run the Hydra node in. Normally you wouldn't use this for a mainnet deployment of a dApp that just wants to use Hydra, but it allows you to evaluate a sequence of transactions and see if they're valid or reject them without needing to go through the process of booting up a Hydra head or reaching peer-to-peer consensus with other nodes. It's kind of just a really stripped down, almost ledger as a service. This could be really useful for testing scenarios or for evaluating incoming transactions in the mempool for your own kind of purposes if you want to build like hypothetical scenarios. And it's also useful as a building block in other protocols. In particular for us, we're going to be using it in Gummyworm to allow kind of a set of watchers to validate the stream of transactions that come out of a Gummyworm node. So in the description, you can find a link to the Hydra GitHub repo, and they have a really great README on getting started, either just cloning their official images, or they have guides down here on getting started from compiling from source. So that's the first step, is go and try that out. As of recording this video, our pull request for the offline mode isn't yet merged, but we're anticipating that being merged today or tomorrow. So by the time that you watch this and try it out yourself, you'll likely have it in the main branch, but if not, you can always try it out from this branch. So once you compile and build that from source, there's some command line flags that you can provide to start it up in offline mode. So let me pause. Our developers that are working on it recorded a small video that I can talk through to demonstrate it working and show how you might use it. Great, so playing here behind me is a recording from one of our engineers that is one of our end-to-end tests, kind of repurposed just to show how everything works. So they're going to go ahead and start up an offline mode. And so this now is running a Hydra node that is sitting there waiting for transactions from an initial UTXO state. This didn't have to go through the layer 1 setting to open ahead and commit and all that. It just kind of was ready to go from the get-go. So they're now going through and building a sample transaction that, so there was an initial kind of starting UTXO provided as a file, and they built a transaction that they can then submit against the chain. This is all kind of just written in the end-to-end test framework that the Haskell or the Hydra node has to make it easy. And so you'll see them build and submit a couple of these and receive confirmation that the transaction was valid. And then we'll build one that's invalid, just to show that it can also serve to reject transactions. That's the primary purpose. So, and these are just random transactions that we built and grabbed. We're loading them from disk and we're submitting them. So you could imagine this could be really useful, for example, for building end-to-end test scenarios that want to test a whole sequence of transactions. It could be useful, if you're monitoring the mempool and want to start up and evaluate those transactions really quickly, kind of really just a ledger as a service, without having to, in this case, we wrote some Haskell code to interact with it, but in principle, you can interact with it over the very excellent web APIs that the Hydra node provides. In our case, we're going to be spinning these nodes up as, from the perspective of the validators that are watching and checking the validity of the transactions that the Gummyworm head operators produce. So we haven't talked in super detail about how exactly the Gummyworm protocol works, but the basic idea is to modularize the custody of user funds so that the Hydra head operators can control the consensus and execution of transactions and go really fast because they're a very small set, but the actual absorption and release of funds can be a completely separate mechanism. And this fits into that other side of it where they're, in order to mediate the release of funds, there's a role for somebody who is validating and watching that stream of transactions. So this was all in Haskell, but if you want to try it yourself, there's some command line flags that you can find either on screen right now or in the description or in the documentation if we've gotten around to writing that documentation by the time you're watching this. So hopefully that was interesting to you and kind of demonstrates the work that we've been doing. And if you do get a chance to try it out, we'd love to hear your feedback. The next kind of step of this, we've gotten it merged, but now it's on the, we're going to be reaching out to the community to have them try it out and get feedback on, what works well, what features would be nice to have, what documentation is lacking, and things like that. And so we'd love to hear any feedback that you have either on Twitter, or you can send it to me in a DM or an email. Great. Have a great rest of your day.